Good day everyone. Today I'm going to create our performance task 7, which is perform this exercise. Use if else statement to create 3 by 8 decoder. And second exercise, use case statement to create 4 to 2 line priority encoder. And lastly is modify the simple 1-bit ALU to utilize an always block of the previous exercise. So first we are going to create if a statement to create 3 by 8 decoder. So I already make my truth table. So this is my truth table. So based in this diagram, we have three input, which is A, B, and C, and we have 8 output, which is D0, D1, D2, D3, D4, D5, and D6, and D7. Then we have 3 inputs, so we come up with this truth table. So in 0, 0, 0, D0 is 1 and the rest is 0. In 0, 0, 1, D1 is 1, D0 is 0, and the D2 and the rest is 0. Then in 0, 1, 0, 0, D0 is 0, D1 is 0, D2 is 1, then the rest is 0. So it's like an decrement of number from D0 to D7. So and this is my logic circuit. Then let's proceed to my code. So this is my code. So we have 3 input and 8 output. So if A is equals to 0, B is equals to 0, and C is equals to 0, then begin D0 is equals to 1 and the rest is 0. Else if A equals to 0 and B equals to 0 and C equals to 1, D is equals to 1, D1 is equals to 1 and the rest is 0. Then if else A equals to 0 and B equals to 1, then D2 is equals to 1. So it's the same from my truth table. And the rest of the code is the most generator, and then my test bench. So let's try to run this. Open my command prompt, run as administrator. Then oops, wrong .v and bvp. Then let's call GTK wave. So this is the output. So in 0, 0, 0, 001, D1 is equals to 1. Then in 0, 0, 0, D0 is equals to 1. 0, 1, 0, D2 is equals to 1, and so on. So based on this truth table and in this GTK wave, somehow correct. And that's all of my in this video. Thank you. So now we will answer our exercise number 2 in performance task 7. So it says use case statement to create 4 to 2 line priority encoder. So create this truth table. So we have 4 output and 4 input and 3 output. So we have D0, D1, D2 and D3, and outputs A0, A1 and V. So in 0, 0, 0, 0, A0 and A1 is 0, IX. It don't care, it is don't care, then V is 0. And if D0 is 1 and the rest is 0, D0 is high priority bit. So D0 is the highest priority bit and the rest is low priority bit. Then A0, A1 is 0, then V is 1. Then in D1 is 1, D0 is X because D0 is less priority bit and D1 is high priority bit, and D2 and D3 is 0, then A0 is 0, then A1 is 1, then V is 1. And D2 as follows: if D2 is 1, D0 and D1 is X because it is less priority bit, and so on. So D3 is 1, then the rest is X or less priority bit. Then this is my logic circuit. Then let's try to run our code. So this is the code. So we have 4 input and 3 output. So then we name our module as priority decoder. Then since the problem is use case statements, so since it is case, we have 4 input, then we put it in this. Then this is 4 bit. We represent our input. So we represent our input as binary. So 4 bit, then 0, 0, 0, 0, 0, 1, then our A0 equals 0, then A1 is equals to 0, then V is equals to 1. Then in 0, 0, 1, 0, then our A0 is 0, A1 is 1, V is 1. So this is basing on the truth table. So our stimulus generator, then my test bench. So let's try to run this. Then let's call GTK wave. So we have 4 input, then 3 output. So in 0, 0, 0, A0 and A1 is X, then V is 0, then in 1 1 0 0 0, then A0 is 0, A1 is 0, then V1 IV equals 1, and so on. So this is my output of 4 to 2 line priority decoder. So that's all, and thank you. So lastly, I'm going to perform my exercise number 3, which is modify the simple 1-bit ALU to utilize an always block of the previous exercise. So I already performed it in my previous exercise, so we just simplify it and utilize it using always block. Then same as our previous or my previous task. So this is my truth table. So if our selector is 0 0, we perform addition. Then if our selector is 0 1, we perform subtraction. And if our selector is 1 0, then we perform bitwise AND. And lastly, if our selector is 1 1, we perform bitwise OR. So this is my code. So I have 2 input and bus of 2 input, then 1 output, and this is my code. So always, then if our selector is 1 1, then it perform this multiplexer. If our selector is 0 1, then R is greater than or less than or equal to XY, then else R is less than or equal to X and Y. Then it perform the half adder. Then if R is less than or equal to X and Y, then it perform the subtractor. Else, if S is equals to 0 equals to our selector is 0 equals 1, then our carry perform the carry. Then perform the bitwise and bitwise OR. And then this is my stimulus generator. Test bench. So let's try this. Let's try to run this. Oh, GTK wave ALU dot BCD. Okay. So as you can see, 0 and 0 0, and our carry 0, our R is 0, then in 0 1, our carry is 0, then our R is 1, and so on. And that's all of my performance task 7. Thank you.